Hello everyone, my name is Samruddhi Mohan Patil. I am from F5CSE Division E. Today I am going to explain the topic electrical machine, especially DC motor, from the subject Basic Electrical and Electronics Engineering. Electrical machines are devices that convert electrical energy into mechanical energy or mechanical energy into electrical energy. In this presentation, we will mainly focus on DC motor, its construction and working principle. DC motor and DC generator. First, let us understand the difference between DC motor and DC generator. A DC motor converts electrical energy into mechanical work. For example, electric fans, mixers, and electric vehicles use DC motors. On the other hand, a DC generator converts mechanical energy into electrical energy. It works on the opposite principle of a DC motor. So we can say that both machines are similar in construction but differs in operation. Now let us see the construction of DC motor. A DC motor consists of various parts which work together to produce rotation. The main parts are yoke, main poles, armature core, armature winding, commutator, brushes, magnetic path, field winding, shaft, terminal box. I will explain each part one by one. Yoke. The yoke is the outer covering of the DC motor. It is usually made of cast iron or steel. The main function of the yoke are it provides mechanical support to the motor. It acts as a path for magnetic flux. So the yoke protects the inner parts and helps in magnetic flux. Main poles. The main poles are mounted on the yoke. They carry the field windings and produce the magnetic field required for motor operation. Each pole has a north and south polarity, which is very important for motor action. Without poles, magnetic field will not be created. Armature core. The armature core is the rotating part of the DC motor. It is made up of laminated iron sheets. Lamination is done to reduce eddy currents losses. The armature core provides a path for magnetic flux slots to hold armature winding. Armature winding. The armature winding consists of copper conductors placed in the slots of the armature core. When current flows through these conductors and they are placed in a magnetic field, a force is produced. This force is responsible for the rotation of the motor. Commutator. The commutator is a cylindrical structure made up of copper segments. Its main function is to reverse the direction of current in the armature winding. This reversal helps in maintaining unidirectional torque so the motor keeps rotating in the same direction. Brushes. Brushes are made up of carbon. They are stationary and press against the commutator. Their function is to conduct current from the external DC supply to the rotating armature. Without brushes, current cannot enter the armature. Magnetic path. The magnetic path is a closed path for magnetic flux. It includes field poles, air gap, armature core, yoke. This path ensures proper interaction between the magnetic field and armature current, which is necessary for motor action. Field windings and terminal box. Field windings are copper wires wound on the poles. When current flows through them, they produce the main magnetic field. The terminal box is used for external electrical connection. It provides a safe and secure point to connect the DC supply. Shaft. The shaft is the rotating spindle of the motor. It is connected to the mechanical load. The mechanical output produced by the motor is transferred to the load through the shaft. working of Working principle of DC motor. Now let us understand the working principle of DC motor. The DC motor works on the principle that whenever a current carrying conductor is placed in a magnetic field, it experiences a force. The direction of this force is given by Fleming's left hand rule. According to Fleming's left hand rule, first finger shows the direction of magnetic field north to south. Middle finger shows the direction of current. Thumb shows the direction of force or motion. All three fingers should be mutually perpendicular. This rule helps to find the direction of rotation of the DC motor. The magnetic of force acting on the conductor is given by F is equals to BIL, where B is equals to flux density, I is equals to current, L is equals to length of conductor. This equation shows that force depends on current, magnetic field strength, and conductor length. When DC supply is given, field winding produces magnetic flux from N pole to S pole. Armature conductors carry current. Using Fleming's left hand rule, upper conductor experiences force towards the right, lower conductor experiences force towards the left. These equal and opposite forces produce torque, due to which the armature start rotating in clockwise direction. In actual motor, many conductors work together so smooth rotation is obtained. Conclusion. So to conclude, DC motor converts electrical energy into mechanical energy. Its construction includes yoke, armature, commutator, brushes, etc. It works on Fleming's left hand rule. DC motors are widely used because of their simple construction and good speed control. Thank you, everyone.